Okay, so in this video we're going to be talking about the planetary evolutions and that, life exists on other planets, but not just other planets, but all planets. And first of all, understand this. I know what you're probably thinking. You're probably thinking that, okay, how can some planets have life on them, if they're either too cold, have a thick atmosphere, again, like Neptune and Pluto could have like a really cold atmosphere, considering that they're so far away from the sun, but yet they still exist. And then there's like, I remember reading that there was like 1,800 and, what was it, like 72 or 62 planets that are said to, or was it 92, planets that are like away from, like past Pluto. Because you look at our solar system, and it's huge. It's like 122 astronomical units. An astronomical unit, again, is 93 million miles, the distance between the sun and to the Earth. And then you take that and you just go right past Pluto with it, and it'd be like 1/3 the distance almost. But you still have like a long ways to go, and that's just one solar system. How many things do we not know that exist? But the idea is this, every planet evolves differently. Over periods of time. You can take it's like it came from nothing and then it was turned into something. Everything is made of energy. Everything changes over time because of time, motion, and even progress would be the same thing. But the idea is that if like for example, if like Earth, obviously you look at Earth and there's life on this planet. But let's say, you look at planets like Venus and Mars, for example. We'll use those as examples because they're closest to Earth. You look at them now. Mars was destroyed by too much volcanic activity and solar wind, so it's just the dust bowl, essentially, is what it is. Venus, on the other hand, is a dust bowl, and its atmosphere has been tainted by sulfuric acid. Literally, it rains metal in its atmosphere. Why is that? Well, somewhere down the line, Venus, something to do with its nature. Something was unbalanced. I don't know exactly how this happened, but somewhere down the line, Venus's rotation stopped. So it's, days on Venus are like super, super longer compared to maybe that on like Earth and, Mars, for example. I think Venus might actually have the longest days because of its slow rotation. So it has the slowest rotation of all the planets we know of at the moment, at least that I've seen anyways. But the idea is that, if it wasn't just the temperature all by itself, I think it's like 864 degrees Fahrenheit off the top of my head, somewhere around there. The idea is that Venus's temperature is so hot that you look at that and there's no way. So for example, I have a wood stove right down here and we burn wood. And usually the hottest I've got it to is like 450 degrees Fahrenheit. That's not even half of that. Well, that's sort of half of that. But, you look at that and it's like, well, that's pretty hot. So, how could something like that survive on Venus? Well, maybe somewhere on Venus there's stuff that's immune to other, it's immune to that kind of pressure and heat. And it's immune to sulfuric acid. I'll give you another example. Take the element mercury. Not like Mercury the planet, but like mercury, like the toxic gas. It's supposed to be the most lethal toxic gas that we know of. Or one of, if there isn't already another one that I might be missing. And it could kill anything. But at the same time, though, there have been biologists mostly that have found that that's not entirely true. Yeah, you could kill other organisms with it, but not all organisms are the same. Like, for example, plants. There are plants that are actually the complete opposite, immune to it, and they actually feed on it, and then they literally purify its surroundings when they ingest this toxic gas, this element that is said to be so hazardous that people should be aware that they're entering something that's filled with mercury or something that could very well be contaminated with mercury poison. So how is that for you? And you take that same idea. Everything evolves differently. Everything is different. For example, how does life get on another planet when it's formed through evolution? For example, when a planet is formed, that material also forms with from the same stuff that fossils can come from. And because take our planet, for example, it's actually supposed to be two planets because the planet Theia crashed into our planet. In case you don't know what Theia was, it was a planet that was somewhere like the size of Earth, or something the size of Mars, crashed into Earth. It destroyed itself, but it bounced out of the Earth's orbit during proto-Earth, and it like the gravity was still there, and it just formed over time. But then eventually these rocks eventually shaped because of gravity and pressure, and that's how the moon was formed right back. Because like, for example, if you, in case you also don't know this, some planets are actually more rounder. In other words, like, because of how fast they orbit. So in acceleration, rotation speeds, pressure, and it just essentially the gravity that's holding it together. So it becomes one, essentially. And so our planet, I mean, Theia could have had life on it, and even fossils that were still alive, sort of, or bacteria, that eventually over time, in 4.7 billion years is a pretty long time, enough to the point where evolution could have evolved over that period of time, and hence that's maybe where we came from, or we came from the stars, yes. But at the same time, though, maybe our DNA was actually from a planet that was in this solar system, and I mean we're still in the same solar system that we're familiar with, but But maybe there's just a different spin on like how our evolution came. So like, not saying that we got into a ship and we flew away, but maybe like we came from this planet and then we just crashed into Earth, and then now we're here because we're already in its atmosphere, and we just evolved over the years. Our material is still there. So you can look at this understanding of you look at that and you're like, oh hey, that actually works. Or maybe we just came from like a different part of the universe, and we're here because again, when planets are formed, eventually, like if like rocks crashing into it, like asteroids and all that, eventually like it carries DNA. That same DNA, again, it might just be a different evolutionary process, but eventually that material is made up of the same thing as everything else in the universe, and everything else, and therefore we evolved into what we are now. So like planets, because all the evolution was just time and motion and progress. It was just there. There was things that even when like living organisms started becoming what they were, like natural selection comes into play, where like in reproduction, you choose what you have sex with, you reproduce, best genetics, and then like over the years, even when DNA started becoming more relevant in our society, when we started really understanding it, it makes sense. Like the more we study it, it seems like the more this is the answer to what we're trying to figure out. And you could say the same thing about other planets. That same idea, but just it happens differently in its own way. Maybe we can say, like, because there's more than one planet, obviously, and maybe on those planets there's life on them somewhere. And we don't have to just look at it like, maybe the inhabitants of those planets necessarily have to just breathe oxygen or all the known elements. Maybe there's a planet out there from another part of the universe that doesn't necessarily need water, and maybe it thrives on toxic gas, for example. I mean, that sounds like a fantasy, but and maybe that's how they live. Again, like we look at some plants and we know that yeah, they need water, and in some cases they need oxygen, but they mostly need carbon dioxide. And I mean, you could say yeah, there's oxygen and carbon, but mostly carbon though. And these plants, they do pretty well with that material, and it just produces what it does, because it takes what it does in and it exhales it out, inhales it, exhales it out. And it just certain, like, or I'll give you another example. There might be, like, you take your digestive system. There's some things that you can't break down, but maybe like what you can't, what your body doesn't need, maybe like something like a decomposers, like flies need, or you know what I mean. So there's more than one way to do something here, but like it's just the evolutionary process, and it's just where we fit into the food chain and society that we become what we are. And even from an evolutionary standpoint, like if we were to think that humans are not necessarily always 100% right about everything, but because again, like Albert Einstein once stated, we've always underestimated things because people just simply don't understand everything. And or to put it more precise, the quote where he said that if one doesn't simply know something, then he's never understood it enough. if people don't know the answer to something, they simply just don't understand it to the point where they need to study it more, and then eventually it will become clear because now they're now realizing it and they can explain it better. So you look at like all the things that humans have discovered versus like all the things that are existing in the universe. The universe is obviously creating so much more stuff that we can even keep up with. So it's like all by itself like an endless process. But when you really think about, like there's so many planets we don't know, so many different galaxies, so many different universes that probably just work the same way our planet does, but in its own way. Like there's a star, planet orbits around it, and maybe there's inhabitants on it. And, you look at this, and you say that the reason why it's able to exist in that mentality is because of the gravity, the atmosphere is right, and the inhabitants were able to become, their organs were able to survive in those conditions, not just because they've evolved differently, but mostly because it worked. It was success. It was what was known as a successful evolution. And I'm not sure if I really just made that up, but that'd be a successful example. It evolved successfully, so it can live in those conditions. And when you really think about like every other planet is different, and other animals are different. Maybe when you hear a scientist say that maybe there's no life on Mars, well, maybe there is, because maybe there's just the fossils could still be there, but maybe there could also be like bacteria that lives on that planet still, and it can survive those conditions because it's already there. And if like let's say that maybe in the past that those planets had, just because we can't see it doesn't mean it doesn't exist. But maybe there's. I mean, again, you don't have to have like, you don't have to have life like that's just as tall as we are and they're walking around like this. It doesn't have to just be that. It could be like ants, or it could be like some sort of Stone Age bacteria that, or even well before that time period. Like amoebas or not amoebas. I'm trying to think what those terms were called, but you could essentially just have insects, and as long as it still counts as a living organism. I mean, hell, what counts as a living organism would baffle some people. Like, you could just have like a single cell that has a nucleus, and that's considered a living organism. And maybe it hasn't evolved necessarily over the years, but I mean, if you can consider that a planet, I mean, this is another thing that's really interesting. I think this takes the record for being like the greatest thing I've ever heard somebody say, even though it sounds stupid. But in the world of science, that's why I'm making this video. You could essentially say that by definition, everything is a living organism, even something that doesn't move, because it's made of material that, because again, everything's made of energy, but it seems like everything is infinite. It seems like everything is made of some material that just, it goes on and on and on, hence, again, infinite. But it's just like, it's alive somehow. Like it needs certain material, nutrients in order to live. It has a mind of its own. Again, some people kind of disclaim the idea that maybe the intelligent design really isn't as accurate as it seems. But again, mind you, humans, it seems like at the same time humans just underestimate everything. Again, you look at the size of an ant, for example. It's a living organism, and yet it lives in a colony of millions. As a matter of fact, those colonies can get along greater than the human race can get along with, it seems like. And you look at these ants, and I mean, like, just even the scientists that they just look at that, or if you want to go even more, it might sound boring at first, but go look at like amoebas or all those little bacteria, like when they split and everything asexually, or they just split in half. You look at those, you just look at it in a microscope, and you just look at like these little things that you just can't see, but they're there though, and they're just like, they're moving around and all that, and they're just doing their own thing. And you think about like how we could go from something like that to what we are, and you really understand that the reason it's the physical, like DNA, RNA, etc., whatever's beyond that. But you have like all these infinite combinations of like physical appearances or physical building blocks like cells and elements and all these things that, it's like the more you learn these things, like the more exciting it becomes, the more like it changes, it opens your mind up more to like all these perceptions that you just don't, you'd be surprised that, like, you're trying to find, like, the next person that either understands this as well as you do, or maybe, you know, they want to learn it just as well as you do. Because when you think about, like, all these things that most scientists discover, most people don't even realize some of this stuff because they don't study it like these people do on a daily basis. So when you look at all the science between like evolution, it's like evolution doesn't have to just be like, you know, just living organisms. It could be everything. You know, or how about this? Beyond everything. You know, because it seems like everything is alive, sort of. Like in a way that, you know, the material it's made of and the fact that it just seems to have intelligence behind it. Like for example, you know, you might look at man-made elements, for example. Like, you know, you might look at some of like material and you might look at it and say, well, maybe it's not necessarily alive, but maybe the material itself is made alive somehow. Like, for example, like you could say, you could look at like examples like all these elements that we have yet to even discover, for example. Because what do we know? What were we up to? Like 119 of them last time I checked. It seems like, you know, everything in evolution is alive because it evolves and it has a mind of its own, or it has this instinct to keep going somehow. But it's like you know how like when some animals. This will be the best way I can explain it. Like, you know how like some animals are just born with a certain instinct? Like there's some things that their parents have to teach them, but then over time that, you know, like take like a wolf, for example. You know, it has like a native instinct to, like some animals are born good hunters, but at the same time though their parents have to still teach them. And at the same time though, you know, a wolf knows how to, like it just seems like they know how to walk. Instinctively, like, you know, like my point is, like, you know, yeah, everything's different, everything evolves differently, but it's just like, you know, you look at all this progress. I'm trying to think of the words to put it in, but it's just the idea is that, you know, everything makes progress by some sort of evolutionary standpoint and by some sort of instinct, intelligence, instinct, and even just the capabilities that, you know, you would need to be able to fulfill these requirements, but it's there, and it eventually becomes a full circle, a full completion. Like, you know, like you look at all these, like we can exist on these planets because the conditions aren't just met right, but because, you know, it worked. Like this cycle we call life, the origins of life. I would say the origins of life aren't just based off evolution, but it's to become something. Become something better. Not necessarily like reincarnation, where like you die and you're just immediately reborn as something else, but like, I mean, you like rather, like there's always something else out there that, you know, is waiting to be achieved, waiting to be known. And at the same time, though, when we look at science, we understand this philosophy that, you know, we have to really push for a better understanding of what we're surrounded by. So in other words, in order to understand something, we simply study it until we have an answer. And, you know, you talk to a lot of scientists that say that, you know, maybe even millions of years from now, like maybe humans will look much different than we are now, and at the same time, though, but those people will still be individuals, and our ancestors, which would be us, would be, you know, maybe they might find this video, if this video still exists in that time period, and they look at that, and if they can make sense of it, they could say that, you know, yeah, there was a huge difference between now and then, or, you know, now and then, and, you know, and then even beyond that. You know, it just, everything gets better, but the only reason why everything gets better is because, you know, there's a vision, there's a dream, and, you know, there's that motivation to want to achieve that dream. And over time, evolution changes people because of their, you know, everything is just in motion. Everything's always you know, everything's always changing because that's just the reality of it. Nothing, I mean, you know, if you can change one thing about something, you got yourself completely different results. Even the smallest detail will make the biggest difference. Like, for example, if you heard that old saying where, you know, the smallest things can make the biggest differences, or something like that. And that's just the reality of life, you know. It'd be really hard to go a long period of time where everything was still the same and nothing changed at all, you know. Unless, of course, you know, like it's technically changing, but just very slowly, mind you. And that's how evolution is. So, and it works just like that, because if you think about it, you know, celestial objects like space and the universe and galaxies and even beyond the universe, you understand that that's the reason why most people don't understand evolution. The people that have yet to accept it, because they really don't believe that everything is always constantly changing, physically, mentally, spiritually, and even what's that, even beyond that, you know, like just going beyond the realm of the unknown and even the realm of science. I know it doesn't sound like it makes sense, but you know, but essentially going beyond what no one else has ever done before, or even you know, what has yet to even happen once from our perspective, or even in the universe's perspective. You know, the idea is that that's what life is. You know, learning something new, making sense of it, passing it on, and just more importantly, doing it. Because if it's possible, then it is. But I mean, but evolution, though, it is true, though, because we see it. As a matter of fact, and this is how I'm going to end the video, and I want you to think about this. Everything is evolutionary, whether we accept it or not. Everything changes, and there's always progress, even when we make mistakes.